Alright, so we'll go through chapters 12 and 13, and we'll just talk about the answer and how we got it. So for question 3 on quiz 12, we pull up all of our files and get them all ready, and we read that suppose we have a set of paired data, and D is x after minus x before. And the null hypothesis is that the mean of the difference should be 0. And the alternative hypothesis is that the mean of the differences are not 0, meaning that the information is different. And the standard population deviation is not known. And so Jordan collects a sample size of 9 and computes that the mean of the differences is 2.2, and the standard is deviating by 3.3. So what is the value of the test statistic? So we set it to t equals our mean after subtracted by our mean before divided by our SD and 3, because square root of 9 is 3. And we get an answer of 2. And so that was just a simple plug and chug. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.403. Use this probability to determine the p-value for Jordan's hypothesis test. Now, for this one, I got 0.081. Because if that's the one that's greater, then the probability of getting less than would also be the same. So you just multiply that by 2. Yeah, I think, I'm pretty sure. What did you get for 4?
For 4, I got 0.081.
Okay, cool. And then chapter 5, question 5. What is the test statistic for this information? And so we look up at our saved data, and we can run it through our SPSS, and we set it to group 1 minus group 2, and run a comparative t-test, because they're the same, they're dependent on each other, they're the same information. And so we get the test statistic of 0.407. And that's just given to us once we run the data correctly. And the p-value would be what the program calls the significant two-tailed value, which we can just read off as 0.689. Now, what is the correct decision based on this evidence? And that would be that we fail to reject the null hypothesis because our p-value is higher than 0.1, which is what our alpha was set to. So question 8. Suppose your alternative hypothesis is instead that the mean of the differences is greater than greater than 0. What is the correct decision based on this evidence? And that would be B. We have insufficient evidence that the mean difference is greater than 0, again because our p score is higher than our alpha, so it means that it's correct. So use the data file given to answer these next 8 questions. We perform a paired sample t-test in SPSS. Again, making sure that it's group 1 minus group 2. And this data comes from this other save. The null hypothesis is that the mean of the differences is 0. And the alternative hypothesis is that it's not. And the level of significance is 0.01. So which is greater? The sample size or the DF? It's the sample size, because DF is sample size minus 1, so it's always smaller. And then what is the p-value? Well, if we run our data through the SPSS, then we can look at our p-value, again, which is the SIG data, and it's 0.001. And so, because it's that, we reject the null hypothesis because their p-value is less than our alpha. Is less than our alpha. You decide to try another alternative hypothesis. This time you use the hypothesis that the mean of the differences are greater than 0, and you keep the same level of significance. Did the p-value increase or decrease? The p-value would decrease. because you divide it in two. Because you don't want what's greater, you only want what's less, so it's a less value. And what decision do we make? Well, we reject the null hypothesis because it is still less than our alpha. So question 14. Based on your response from the previous question, what conclusion can you draw? And we have sufficient evidence that there is a mean difference between the two groups because the mean difference isn't zero. There's differences in the data. So there's differences between the two. And as we have seen, the p-value depends on an alternative hypothesis. In general, which hypothesis will give the smallest p-value? And that one, we're not sure. Sometimes it might be one, sometimes it might be the other. It depends on how the data is set up. So it wants us to determine the confidence interval between the two groups using groups 1 and 2. And if you run a t-test through the SPSS program, then it just tells you what that confidence interval is. So for the for the point estimate, that would be 11.955, or our mean value. And what is the margin of error? Well, we find that by taking our upper value, which we have given to us, and subtract our mean. So 18.607 subtracted by 11.955 gives us 6.652. And then we can just simply read off the last two. The lower bounds is 5.303, and the upper bounds is 18.607. So that should be that for 12. So going on to 13. What question number was it that you had trouble with?
Okay, so with 13, where I was getting confused was how to find everything in SPSS.
Okay. So if you...
I was so confused by that.
So if you can...
Let me just pull it up really quick. The first one.
Yeah. So this one you had to do some coding before you ran the data.
Yeah. So that's where I figured out how to do that.
Uh-huh. Hold on, my internet's freaking out because I'm trying to open SPSS. So, do you have it open?
Yes, I have it open now.
Okay, and you have the dentist bills?
Yeah, the dentist bill, one column in the city.
Okay, so what you do is you want to code the data by city first, because there's two cities. There's Idaho Falls and Rexburg. Yeah. So you go to analyze, or no, transform. You go to transform, and it says automatic recode.
Okay. I guess we do city.
Yeah, so you click on the city and bring it over.
Okay.
And then you have to rename it. So type in city_code in that rename box right below it.
Score code?
Yeah.
Okay.
So let me just pull that up real quick.
Okay.
So transform, automatic recode, city, and I did city_code and clicked add new name.
Okay.
And then OK. And what it should do is create a third column of data of 1s and 2s. And the 1s are Idaho Falls, and the 2s are Rexburg.
Okay, yep, I got that.
Alright, so then you go to analyze, compare means, and then these are independent tests, so you do the independent samples t-test.
Okay.
And your test variable is the dentist bill. And then you...
Dentist bill.
Mm-hmm.
And then the grouping is the score code?
Yeah, is your city code. And then you have to click define groups. And group 1 is 1, and group 2 is 2. And then
1 is 1 and group 2 is 2.
Yep. And then you just hit OK and run the data.
Okay.
And because our class always assumes that they're not equal because we run a null hypothesis, we always look at the bottom column. We don't look at the first row. Because the first one is equal variances assumed. Yeah, just the bottom one.
Okay, so for the t-value, did you get negative 0.434?
I did, yes.
Okay.
Yeah.
That helps a lot.
Sorry, you cut out.
Homework quiz. Have you homework?
I haven't done the homework quizzes yet.
No, because
yeah.
I'm trying to figure out, because I think we do the same process.
Yeah, you do basically the same thing. You just have to make sure that you're running the data right. And like, if you put group 1 is 2 and group 2 is 1, then all that happens is your t-score is flipped from a positive to a negative. And either one's right because your t-score is really your z-score, and that has both a positive and negative value.
Yeah. Okay.
Yeah. So there was a trick question in here where it wanted the standard deviation for just one set of data, for just the Rexburg.
Yeah.
So what you do is if you already have your SPSS pulled up, you just delete Idaho Falls, and then go to Analyze, Compare Means, and select your dentist group, and it'll come up with your means and your standard deviation. So.
Okay, so we want to go through it really quick?
Yeah. I'll just glance over it. So for question 3, it would be both A and B. You need a simple random sample and the mean normally distributed for each group to compare the tests with each other, because then there's good data. The test statistic for a hypothesis test comparing the two is still a t-score. The two samples are independent if subject 1 will tell you nothing about subject 2. The degrees of freedom for 6 is a calculated value of 37.996.
For degrees of freedom?
Yeah. Because it's a Steinhardt equation to find it, it's an estimate.
Yeah.
And then what is the standard sample deviation for Rexburg? That's where you have to delete one set of data and then run the analysis through SPSS. And I got a standard deviation of 206.637. Hopefully that's
6.637?
Yeah, 206.637.
Okay.
And then the test statistic when we run that data should be, like we did just now, negative 0.434. And then for number 9, our p-value, because we're looking for our alternate hypothesis is that 1 is less than 2, we take our p-value and divide that by 2, I believe. I got this wrong before. But
the p-value?
Yeah. Did you do this one?
I haven't turned it in yet.
Oh, okay. What'd you get?
No, so, I mean, I just looked at the SPSS.
Right, I did the SPSS value. Yeah, 0.396 didn't work.
0.396?
Yeah.
Isn't it 0.666?
Oh, you know what? It might be. What is the correct conclusion based on this evidence? That would be we failed to reject the null hypothesis because it's larger than our alpha. 11 is also stating that if we say 1 is not equal to 2, that's actually false because of our data. It shows that they probably are equal. So we have insufficient evidence that the mean dentist bills between the two cities are different. 12 would be B. 13, I got negative 0.845 for the p-value.